Dear students, we are solving the IB Math AHL past papers, and currently we are solving the IB Math AHL May 2022 paper 1 time zone 2 past paper. Today we will be solving the question number 3 of this paper, and you will be getting the links to all the previously solved questions of this paper. That means the first two questions of this paper and of the other papers in form of playlist in my channel NS Online Math Tutoring Classes. So without any further delay, let us start answering question number 3. The maximum mark is 8. It says a function f is defined by f of x equal to 2x minus 1 over x plus 1, where x belongs to the set of real numbers and x is not equal to negative 1. Subpart E says the graph of y equals f of x has a vertical asymptote and a horizontal asymptote. Write down the equation of I is the vertical asymptote. In order to get the vertical asymptotes equation, we equate the denominator to 0. So x plus 1 should be equal to 0, and this will be giving us the value of x as negative 1, which will be the equation of the vertical asymptote. So x equal to negative 1 is the vertical asymptote. Okay. Next, the horizontal asymptote. For the horizontal asymptote, we test the degree of the numerator and the degree of the denominator. What is the degree? Degree of a polynomial is the highest power of x present in that polynomial. In the numerator, we are seeing it is a linear function. The highest power of x is x to the power of 1. And for the denominator also, the highest power is of x is 1. So both of them are linear functions. Therefore, they have the same degree. The numerator's degree is equal to 1. The denominator's degree is also equal to 1. If you have the degree of the numerator equal to the degree of the denominator, then the horizontal asymptotes equation will be y equals the coefficient of the term containing the highest power of x from the numerator, that is 2, divided by the coefficient of the term containing the highest power of x, which is 1, in this case in the denominator. So it is 2 divided by 1. So the equation is y equals 2. This is the equation for the horizontal asymptote. Okay. So we have completed answering subpart A. Subpart B is on the set of axes below. It is not below, it is actually over here. Sketch the graph of y equals f of x, and on your sketch clearly indicate the asymptotes and the position of any points of intersection with the axis. That means the x-intercept and the y-intercept. Okay. Now coming to this graph, I have drawn the two asymptotes. This horizontal asymptote is passing through this point 2, so it is y equals 2 line. And the vertical asymptote is passing to negative 1, so it is x equal to negative 1 line. Okay, these are the two asymptotes that I have already drawn because I wanted to save some time. And now we come to the axis intercept. If we try to get the y-intercept, for the y-intercept, the x value will be equal to 0. So 2 times 0 minus 1, that is minus 1 in the numerator, divided by 0 plus 1, which is 1. So the y-intercept will be a point with coordinates 0 and negative 1. So it will be 0 and negative 1. This will be the point, the y-intercept. And what about the x-intercept? For the x-intercept, the y value will be equal to 0. The y is this. Y is equal to 2x minus 1 over x plus 1. So y is equal to 0. That means this fraction value is equal to 0. And whenever we this rational function, for this rational function, the numerator should be equal to 0. Because whenever we have a fractional expression that is a rational function, if the rational function value is equal to 0, that implies the numerator is equal to 0. So 2x minus 1 should be equal to 0. And if 2x minus 1 is equal to 0, what will be the value of x? X will be having the value of half. So the x-intercepts coordinates will be half comma 0. Okay. So this can be taken as the x-intercept half comma 0. Okay. So let me just write this as 0 comma negative 1, and this is half comma 0. Okay. And now we know how the function graph will look like. We know that. So we will be just drawing a freehand sketch of the function graph. So it will be more or less of this type. So this is the function graph of f of x equal to 2x minus 1 over x plus 1. Okay. Fine. We are done with this sketching. And in case you want, you can write the equations for these asymptotes. This is y equals 2 and that one is x equal to negative 1. Okay. Fine. And then we come to subpart C, hence. Hence means could be taking the help of the previous subparts. Hence, solve the inequality 2x minus 1 over x plus 1 is greater than 0 but is less than 2. That means the y value is more than 0, that is, it is above the x-axis, but the y value is less than. So which part of the graph should we be looking at? It is this part. This part. It is this part. Okay? I will not be taking this point where the y value is equal to 0. It should be more than 0. So I will be excluding this point. But from here, it will be just continuing. And it will not be going above 2. So it is this portion. So what all x values can we have in the solution set? The x value for y equal to 0 is half. So we cannot include that half. And we will be having in every x value, every possible positive x values, real numbers, which will be greater than half. So the solution set is x is greater than half. Okay. So this was the vertical asymptote and this was the horizontal asymptote. And this is the answer for the subpart C. Since it is not including the equal to sign, the answer will also not be including the equal to sign. It will be x is greater than half, because when x is equal to half, y is equal to 0. But over here they are saying the y value, which is the 2x minus 1 over x plus 1, should be greater than 0. Okay. Subpart D. Solve the inequality 2 times absolute value of x minus 1 over absolute value of x plus 1 is greater than 0 but is less than 2. Okay. If you are afraid of this part, the absolute value of x, let us do one thing. Let us substitute. Let a is equal to absolute value of x. Okay. So therefore, we have the inequality as, we can write the inequality as 2a minus 1 over a plus 1. This should be greater than 0, but this should be also less than 2. Okay. So now we, we get two inequalities from this single relation. Okay. So we are having the first inequality as 0 is less than 2a minus 1 over a plus 1. Okay. And the second inequality is 2a minus 1 over a plus 1 is less than 2. Okay. And now we will be multiplying both sides of this inequality by a plus 1. Since a is a positive number, because a is the absolute value of x, which is positive. So a is a positive number, 1 is a positive number, they are getting added. Therefore, a plus 1 is a positive number. And if we multiply both sides of an inequality with a positive number, the inequality sign remains unchanged. So we can write an a plus 1 times 0 is 0. So we can write this as 0 is less than 2a plus minus 1, or 1, I'm adding 1 to both the sides. 1 is less than 2a, or half is less than a. Okay. So what is half? Half is, sorry, what is a rather? A is absolute value of x. This is greater than half. Okay. Now what does this mean? If I draw the number line, this is suppose the number line I am having. This is 0, this may be 1, this may be 2. This is -1, this is -2, and so on. Okay. So this position is half and this position is -half. Clear? Now, absolute value of x is greater than half. If I take this number 1, if x is equal to 1, 1 is definitely a positive number and 1 is greater than half. So the solution set of x will be containing the number 1, will be containing the number 2, will be containing every real number which is greater than half. So one possible solution is x is greater than half. Since it is the absolute value, we have to go to the negative side as well. So suppose I take this, this is what? This may be, I can take this maybe as -1 over 4, this point. Okay. So if I take x value as -1 over 4, what is the absolute value of -1 over 4? It is 1 over 4. And 1 over 4 is not greater than half. So we cannot take this value. But can we take -1 as the x value? What is the absolute value of -1? It is +1. And +1 is definitely greater than half. Same with the -2. Absolute value of -2 is +2, which is greater than half. So we will be taking all the real number values which are, and -1 is less than -half, -2 is less than -half. So we will be taking all the negative real number values which are less than -half. Okay. So the answer will be x is greater than half or x is less than -half. Okay. Now we have got these two sections. Now, from this first inequality, now let us come to the second inequality. Again, I'll be multiplying the entire inequality by a plus 1, and this will be giving us 2a minus 1 is less than 2 times a plus 1 is 2a plus 2. And I can cancel 2a and 2a. That means I can subtract 2a from both the sides. And what am I having? I am having negative 1 is less than 2, which is always true. Doesn't matter what is the value of x, negative 1 is always less than positive 2. So we are not getting any x value from that part. Therefore, our answer is x is either greater than positive half or x is less than negative half. Okay? This is the answer for our subpart D, and this completes our answering of question number 3. And thank you for staying with me till the end. And since you have stayed with me till the end, I am assuming that you have liked my explanation. So I would request you to give this video a like, and please share this video with your friends so that even they can get benefited by watching this video. And please do not forget to subscribe to my YouTube channel. It will be motivating me to make more math videos for you. And in case you have any questions, any doubts, please feel free to write to me in the comment section, and I'll be trying to answer your and clear your doubts as much as possible. Okay? And I'm Nilanjana Sanyal. I'm an online IB Math ASL and HL level tutor. I tutor students from both within India and outside India, and I offer both one on one sessions and small group online tutoring sessions to my students. And currently, you are seeing I am uploading these videos in my YouTube channel, and we will be I'll be uploading the very next question, the answer for the very next question, that is question number 4 of this same paper, very soon. So we meet in our coming session. Till then, bye.